This video is on solubility curves. So before we can read a solubility curve, we have to understand what the word solubility means. Solubility is the maximum amount of solute that can be dissolved in a given amount of solvent at a given temperature. So solubility has to do with solutions, so we have our solute dissolved in our solvent. The solubility of a solution changes based on the temperature of that solution. This makes sense because we've already talked about dissolving, and we know that the warmer our solution, or the higher our temperature, the easier it's going to be to dissolve our solute in our solvent. So as we increase temperature for a solid, that is going to increase our solubility. We can have different levels of solubility. We can have a saturated solution, and this solution is going to contain as much solute as possible at a given temperature. In the solution, all the solute dissolves. However, if we were to add more, it would not dissolve. This solution would look clear and colorless unless our solute had a color to it, but it would be a clear solution that you would be able to see all the way through. An unsaturated solution contains less than the maximum amount of solute possible at a given temperature. Here again, all my solute dissolves. And if you add more, it too will dissolve. This will look similar to a saturated solution, so looking at them you couldn't tell them apart. Here again it would be a clear solution and everything would be dissolved. A supersaturated solution contains more than the maximum amount of solute possible than the normal at a given temperature. So this means that we will see solute as a solid at the bottom of our beaker, or bottom of solution. So if I were to have a solution that was supersaturated, I put in my solute and I'd add solute and add solute and it'd dissolve and dissolve and dissolve, and then suddenly I would see that it's no longer dissolving and I would have a little pile of solute at the bottom of my beaker. Now the amount of saturation I have can be quantified as concentration. So concentration is the measure of the amount of solute that is dissolved in a given quantity of solvent. So how much solid we tried to dissolve into our liquid. The units on this is molarity. And you'll sometimes see something written as a 2 molar solution. So that just tells you that the concentration is 2, and that has to do with the amount of solute given in so much volume of solvent. We can have a dilute concentration where only a small amount of solute is put in, or we can have a concentrated concentration where a large amount of solute is put in. So if I were to have 2 beakers, my dilute beaker would have a very light color to it. My concentrated beaker would be very dark because it would have much more solute dissolved into it. We have several factors that affect our solubility, or how much will dissolve in a solvent. We've talked once about the idea of polarity, where like dissolves like. Water is polar and dissolves other polar compounds. whereas oil is nonpolar and dissolves other nonpolar compounds. We also know that water and oil do not dissolve each other. So if I am looking at creating a solution and I use oil as my solvent, I would need to have a nonpolar compound being dissolved into it to make my solution. And same thing with water. Other factors that affect solubility are temperature and pressure. Temperature, we can either have high temperatures or low temperatures. A high temperature will result in greater solubility of solids, whereas a low temperature will result in a greater solubility of gases. So something is cold, more gas will be in the water. Something is warm, more solid can be dissolved in the water. For pressure, if I have a high pressure, that's going to result in a greater solubility of gases. Changes in pressure do not affect the solubility of solids and liquids. So when we look at solubility and ideas of hot and cold and pressure, we can look at soda. If I were to have a glass of soda, my cold soda would have more fizz to it, or more carbonation. Warm soda goes flatter quicker. Along those lines, my fizz, or flatness, has to do with my amount of carbonation. In order to create carbonation in my soda, I have to put the soda under pressure to keep carbonation in the liquid. I know that once I open my soda, I hear that psst sound. That is the pressure leaving my container, and when that happens, you notice a bunch of bubbles rush to the surface. When those bubbles rush to the surface, that is the carbonation, or the dissolved gas, exiting the liquid of my soda. The information about solubility is given on solubility curves. These are graphs that talk about the temperature of different solutions, and they tell us the grams of solute that can be dissolved in 100 grams of water. Well, notice when we look at this curve, we have many different compounds. We are told that we have gases with the dotted line and solids with the solid line. We are told the temperature range from 0 to 100, and my grams of solute per 100 grams of water from 0 to 150. So the first thing we need to notice are our axes. Our y-axis has a label of grams of solute per 100 grams of water. What that means is if I were to have a beaker with 100 grams of water in it, this amount would be the number of grams of my particular solid or gas that I could dissolve into my 100 grams of water. My x-axis is my temperature in Celsius. I would not have a Celsius lower than 0 degrees because lower than 0 degrees my water would freeze. I have 3 different places that a point could be on my graph. I could have a point on these lines. That would indicate a saturated solution. A saturated solution would mean that on the line, it indicates the amount of solute able to dissolve at each temperature. So for instance, here at my point, this point on my line tells me that at 50 degrees Celsius, I can dissolve approximately 85 grams of potassium nitrate in 100 grams of water. If I were to have a point above the line, so let's say looking at a point here above this line, well, that would indicate that more solute, here 100 grams, was trying to be dissolved when really I could only dissolve 85 grams. So that would constitute a supersaturated solution. If I were to have a point below my line, let's say here at 70 grams, still looking at potassium nitrate at 50 degrees, my point is below the line. My maximum amount was 85 grams, but now my point, I'm only dissolved 70 grams in. This amount is less than the maximum amount of solute that was dissolved. This results in an unsaturated solution. Let's look at a couple of different points of potassium chlorate. Potassium chlorate is this line here in red. On my line in red, I'm looking at a temperature of 50 degrees Celsius. I want to know the saturations at 3 given masses. At 10 grams of solute, I go to 10 grams and across to 50 degrees Celsius, and I put a dot. I notice that this mark is below my saturation line. This results in an unsaturated solution. I go to 23 grams, 50 degrees Celsius, and I notice that this point is on my line. This is a saturated solution. Finally, I have my mass of 30 grams. 30 grams across at 50 degrees, and notice is above my line, so this is supersaturated. The last thing I can do is look to see how much would precipitate out. Precipitate out means become a solid. Or go from being dissolved to undissolved. I'm going from 50 degrees to 40 degrees. So I notice that at 50 degrees Celsius, my saturated amount that I can have is 23 grams. So I was at 50 degrees Celsius. Then I cool my solution down to 40 degrees Celsius. At 40 degrees Celsius, I can have approximately 18 grams dissolved. So my solution at 50 degrees Celsius gets cooled down to 40 degrees, and now only 18 grams can be dissolved in my solution. Where did my 5 grams go? Well, those 5 grams precipitated out and are now a solid at the bottom of my beaker.